Hey guys, today's video is about solution concentration and specifically the concept of molarity. So you can see here that I have two solutions of copper chloride. And clearly this one, which is a darker color, is a concentrated solution and this one is more dilute. Well, if we want to quantify the description of these, not just the words concentrated and dilute, but give numbers to it, that's going to involve a concept known as molarity. And molarity is defined as the moles of solute, in this case it would be copper chloride, per liter of total solution. And we denote that measurement with a capital M. So let's put some numbers to these two examples. Let's suppose that this left-hand beaker contained 1 entire mole of copper chloride. My periodic table tells me that would be 134.45 grams of copper chloride. And the beaker on the right, which is more dilute and doesn't contain as much, only contains 1/10 of a mole of copper chloride. Now the two samples are alike in that they each contain 1,000 milliliters of total solution, or 1 liter. So to calculate the molarity of each, we simply take the moles of solute and divide by the liters of solution. So this beaker on the left, which contains a mole of copper chloride in a liter of solution, is known as a 1 molar copper chloride solution. This double-decker unit, moles per liter, is written capital M. And then the beaker on the right, which contains only 1/10 as much, it contains 1/10 of a mole of copper chloride, still in a liter of solution. So that one is labeled 0.1 molar copper chloride. All right, so let's look at some applications of molarity. Oops, here's my kitty. Sorry, we'll call that a technical difficulty. Okay, so here's the question. What's the molarity if you add 7.84 grams of copper chloride to enough water to make 250 milliliters of solution? Okay, so we're going to use this funny looking flask called a volumetric flask. And to this flask, we're going to put in 7.84 grams of copper chloride, and then we're going to fill up with distilled water until the total solution comes up to that etched line. That's what this type of flask is for. It's for measuring a very precise volume of total solution. All right, so to calculate the molarity, we need two pieces of information. We need to know the moles of solute, and that will go in the numerator, and then the liters of solution in the denominator. Well, my problem didn't tell me moles of copper chloride, but it did tell me grams. And I know that using the periodic table and molar mass, I can convert grams of copper chloride into moles. Okay, secondly, in the denominator of my division problem, I'm going to need to know the liters of solution. Well, I'm given 250 milliliters. That's a simple conversion, 250 milliliters, and then I multiply by this equivalence that says there's 1,000 milliliters in a liter. Milliliters cancel out. And so my 250 milliliters is also equivalent to 0.2500 liters. All right, now I've got moles of solute for my numerator, and I have liters of solution for my denominator. So I'm simply going to divide using my calculator, and I come up with 0.233 moles copper chloride per liter. Again, this moles per liter unit is more commonly written this way with a capital M, and it's read 0.233 molar copper chloride. All right, let's look at another example. Oh, you know what? Before we go to another one, I just want to show you how that same problem could be done a little more efficiently. So remember, we had 7.84 grams of solute, 250 milliliters of solution. I can simply say, I know I need my solute in the numerator. Here's what the problem gives me. And I need total solution in the denominator. Now, recognize that my numerator is in grams and I need it to be moles. So I'm going to apply this molar mass step. Grams copper chloride, divide out. So now I have moles copper chloride in the numerator. That's good. In the denominator, I need liters. So I'm going to convert these milliliters into liters. And I have liters in the denominator. So multiplying across in my numerator and then divide by, remember when you have a lot of stuff in the denominator, use parentheses. And that gives me 0.233 moles per liter, or 0.233 molar. So this is all doing the entire problem in one fell swoop, and you may prefer that rather than doing it piece by piece. All right, now we're ready for our second example. How would you make 375 milliliters of a 0.28 molar copper chloride solution? Okay, so when you read a problem which contains a molarity, I would like you to train yourself to rewrite it 0.28 moles per liter. That's what the capital M stands for. And I really don't want to see you writing this capital M within the problem as part of your calculation. I want to see it broken out. Okay, I am asked to make 375 milliliters of the solution, and I know I want to end up with this molarity. All right, so the first thing I'm going to do is remind myself of this equivalence. 1,000 milliliters is the same thing as a liter. So if I'm given milliliters in the problem, all I have to do is divide it by 1,000 to convert it into liters. And you can do that in your head. You don't have to show that work. So what I'm going to do here is take that volume that I want to make, expressed in liters, and then I'm going to multiply it by the molarity, 0.28 molar. Notice I've written it, this double-decker unit. And by setting it up that way, my liter units divide out, and I have this many moles. Okay, unfortunately in my lab, I don't have a mole counter. So instead of stopping the problem right here, I'm going to choose not to calculate it at that point, but just to continue on and recognize that an answer in moles doesn't do me any good, but I can again use molar mass to come up with an answer in grams. So how would I make this solution? I would mass out 14.1 grams of copper chloride, put it into my 375 milliliter flask, add a little bit of water, swirl to get it to dissolve, and then continue to add distilled water until the total volume hits the 375 milliliter mark. Okay, let's look at another example. Let's suppose that you need 0.085 moles of copper chloride for a particular reaction. And all you have available is a solution that's labeled 1.32 molar copper chloride. So this is how much I need. My issue is how much of this should I pour out? How much should I dispense so that I end up with this many moles of copper chloride? Okay, so again, when a problem gives you a molarity using this capital M, I want you to rethink it this way. Okay, now Some people get a little bit hung up with where to start the problem. Whenever your problem contains two numbers, one of them being a molarity, I want to tell you that you're never going to start with that. Don't start with molarity. Instead, start with your other number. So 0.085 moles of copper chloride is what I want. And now I'm going to use my molarity, but you see how I've flipped it upside down? What I'm essentially doing here is dividing by molarity. But what's guiding me is that I'm starting with moles, and to make that unit divide out, I need 1.32 moles in the denominator per liter in the numerator. So now I multiply and divide, and my answer is 0.064 liters, or multiply liters by 1,000 to turn that into milliliters. So I grab this bottle of concentrated copper chloride, and if I pour out 64 milliliters, I will know that in that 64 milliliters, I have the 0.085 moles of copper chloride needed. All right, one final type of problem you might encounter with molarity. You need, this time, 300 milliliters of a 0.46 molar copper chloride solution. And what you have is a more concentrated solution, 1.5 molar. So how can I use some of this and dilute it with water so that I end up with 300 milliliters of this more dilute version? Okay, so again, I have some concentrated, sometimes that's called stock solution or the original solution, but it's very concentrated. And I want to end up with a dilution that's only 0.46 molar. And I want to have 300 milliliters of that. All right, so the first thing I need to ponder is how many moles of copper chloride will be in my final dilution. I know that I'll have 300 milliliters of it. It's going to be 0.46 molar, remember capital M, moles per liter. I set it up this way so that liters divide out. So in this final dilution that I'm making, there will be 0.138 moles of copper chloride. Okay, so the next thing I need to consider is, how do I get that many moles from that stock solution? Okay, well, the 0.138 moles of copper chloride from this stock solution that is 1.5 molar, again, capital M, is moles per liter, and I'm putting the moles part in the denominator so that that unit divides out. And my final answer is 92 milliliters. So if I pour 92 milliliters of this concentrated original solution into my empty flask, and then I continue to add distilled water until my total volume of solution is 300 milliliters, that will give me a dilution that is 0.46 molar. Now, I want to show you a shortcut for this type of dilution problem. The shortcut uses this equation, which I'll refer to as the MOVO equation. So this equation tells us that the molarity of the original solution times the volume of the original solution that you're going to pour out, that product is going to be equal to the molarity of the new dilution times the volume of this new dilution you're making. Okay, so let's see how that works. In this problem, I had molarity of the original. The volume of the original was what I was trying to determine. I knew the molarity of the dilution and the volume of the dilution that I wanted to make. Solving for VO, volume of the original, has me dividing both sides by 1.5, and I get my same answer of 92 milliliters. So this equation, this MOVO equation, comes in really handy when you are asked to make a dilution. So keep that one in mind. Remember that molarity is equal to moles of solute over liter of solution. Remember that in a problem, if you are given the molarity, remember to rewrite it double-decker. Okay, guys, you'll have lots of chance to practice all of those different types of problems. Hope that helped.